Hello, welcome to Ababil Math World. Today we are going to solve the equations cube root of x plus cube root of y is equal to 13 and square root of x plus square root of y is equal to 35. X and y, the values we have to calculate. So for this purpose, so how to solve this? Cubing on both sides, squaring on both sides for the second equation. It becomes this type of cubing and squaring makes the equations complicated. So here to get the answer in an easy way, here I am going to take let x is equal to a to the power of 6 and y is equal to b to the power of 6. Why I have to take a is equal to x to the power of 6 and y is equal to b to the power of 6? The idea I have is here the exponent of x is 1 by 3 and in this equation the exponent of x is 1 by 2. This similar is the case for y also. So the denominators of the exponents of x and x are 2 and 3. The LCM of 2 and 3 is 6. So if I take a to the power of 6 and I write here a to the power of 6, a to the power of 6 whole to the power of 1 by 3, it becomes a square. And here a to the power of 6 whole to the power of 1 by 3, it becomes uh, a to the power of 3, a cube it becomes. Similar is the case, b square and b cube I get it. So I can remove this fractional powers, whole to the power of 1 by 3 and whole to the power of 1 by 2. I can get integral powers. So this is the idea I have. So that's why I made this substitution. And even x to the power of 12, x to the power of 18, all these are also useful. We can take, but it becomes complicated. The least possible value of the exponent we have to take. So here it is 6. So after substitution of this one, what I get? So the equation 1 becomes a to the power of 6 whole to the power of 1 by 3 plus b to the power of 6 whole to the power of 1 by 3 is equal to 13. And equation number 2 becomes a to the power of 6 whole to the power of 1 by 2 plus b to the power of 6 whole to the power of 1 by 2 is equal to 35. So after simplification, 6 times 1 by 3 becomes square. So a square plus b square is equal to 13 and a cubed, this is a cubed plus b cubed is equal to 35. These are the two equations I have. So if the given equations I denote by 1 and 2, so these equations which I have here at this moment I can call equation 3 and this is equation 4. We have to solve these equations. So here the solution I have to get it. So the values of x and y I have to get, but here the values of x and y I have to get, and x and y are now in terms of a and b. To solve this a and b, first the integral values which satisfy this a square plus b square is equal to 13 I have to search. So if a is equal to 1, I say substitute. When a is equal to 1, a square is 1 and 1 plus b square is 13, b square becomes 12 and b cannot be an integer. So a is equal to 1 will not give integral value for b. So if I take b, a is equal to 2, what do I get? When a is 2, 2 square is 4. When 4 is subtracted from 13, I get 9. B square is 9. When b square is 9, b is plus or minus 3. So for a is equal to 2, I am getting integral value for b or integral values for b. So this is useful for me. So now what I can do? So let me take a is equal to 2. So which gives 4 plus b square is equal to 13. So taking 4 to this side and subtracting from 13, it becomes 9. Then b square is 9. Then b square is 9. B is plus or minus 3. And here by taking a is equal to minus 2, it becomes plus 4 again, and the same answer I get it. So it is not only for a is equal to 2, even for a is equal to minus 2 also the same values we get for b. So a is equal to plus or minus 2, I am getting the values of b which are plus or minus 3. So a is equal to 2 I have substituted and I have verified it. Now next integer I take a is equal to 3. So when a is 3, see it, when a is 3, suppose a is 3, that implies 3 square, 9 plus b square is equal to 13. So b square is 13 minus 9, 4. When b square is 4, b is equal to plus or minus 2. Once again here if I take a is equal to minus 3, will it make any change? No. When a is minus 3, I take a square becomes again plus 9, b square is plus b square is equal to 13, b is equal to plus or minus 2. So a is equal to plus or minus 3 I take, then the value of b which I get is plus or minus 2. And when I take higher values of a, like a is equal to 4 or a is equal to 5 and so on, I cannot get integral values for b so that it can satisfy a square plus b square is equal to 13. So these are the only possibilities. The possibilities are when a is plus or minus 2, b is plus or minus 3. When a is plus or minus 3, b is plus or minus 2. But the condition is the values which I obtained here should satisfy equation 2 also, which is root x plus root y is equal to 35. And here in terms the equation is changed to equation number 4, that is a cubed plus b cubed is equal to 35. Here I am substituting a and b, not x and y. So the values of a and b directly if I substitute in this equation 4, it should satisfy. So as the power contains odd number cube, so if I take plus value for a, the same plus value for b I have to take it. So let me take a is equal to 2 and b is equal to 3 and see whether it is satisfied. A cube, 2 cube 8, b 3, 3 cube 27. So 8 plus 27 is 35. It is okay. So now when I take a is equal to minus 2 and minus 3, when a is minus 2 and minus 3 is taken, so here when I substitute a is equal to minus 2 or b is equal to minus 3, it completely makes the answer minus negative, that is minus 35 I am getting, but on the right hand side I have plus 35. It appears that a is equal to minus 2 and b is equal to minus 3 does not give solution for this one. Okay, at this moment we can accept it. And in the same way, b is equal a is equal to 3 and b is equal to 2, both positive values if substituted here, the right hand side 35 obtained, that is 3 cube 27, 2 cube 8, 27 plus 8 is 35. Similar is the case. It appears that minus 3 and minus 2 does not satisfy it. Okay, whatever it may be, now we can go for the values of x and y. Here I have the values of a and b, but my aim is to find the values of x and y. So what is x? This is important here. I am arriving to the very important step here. I have not said that x is equal to minus 2, y is equal to minus 3, and x is equal to a is equal to, a is equal to minus 2 and b is equal to minus 3. Similarly, a is equal to minus 3, b is equal to minus 2. I never said that these are not solutions, but what I said, it appeared that equation 4 is not satisfied when these negative values are substituted. Only so much I have said so far. Now coming to this stage, a crucial stage. So x is equal to a to the power of 6. So here I want x, that is a to the power of 6. X is equal to a, if I take plus 2 or minus 2 whole to the power of 6, it won't make any difference at all. So here that's why I take both the values. X is equal to plus or minus 2 raised to the power of 6. This gives, what is 2 to the power of 6? I know 2 to the power of 5, that is 32. So 2 to the power of 6 is multiply 32 by 2, which gives 64. Whether a is positive or negative, x is positive here. x is 64. When a is plus or minus 2, then b is plus or minus 3. So taking plus or minus 3 and rising whole to the power of 6. So as here power 6 is taken, whether 3 is plus 3 or minus 3, it won't make any difference. I get positive value for y, and the value of y which get for this one is minus plus 3 or minus 3 whole to the power of 6. I know 3 cube. 3 cube is 27. Of course, 27 square is also known to me, that is 729. So this is 729. So x is 64, y is 729. This is one solution. What can be the other solution? Just changing the values of a to b and b to a. That is plus or minus 3 here and plus or minus 2 in y. So then the other possible values are x is equal to 729 and y is equal to 64. So these are the solutions. So if you like this video, please subscribe to my channel. Thank you for watching.